Yeah, so I represent Enarx, and I'll talk this through. So we've heard lots about TEs already, and it's actually, I have to say thank you so much to Felix for the first talk, which saved me so much time. So let's say we all agree that TEs sound great. There are some problems. If you're an end user, there really are some issues. The first one is that, if you want to be deploying on different platforms, SGX, SEV, we've heard a lot about, and TDX coming up, and whatever else, you may need to do separate development for each. And there are different SDKs out there, and that means that unless you choose the SDK which has a language support that you want already, you may have some problems. Another big one that's been talked about a little bit already today is different attestation models. These are difficult trust decisions which often need to be made dynamically. And then, of course, if problems do come up, let's say vulnerabilities are discovered, as happens from time to time, you need to be able to, in production, decide, I'm not going to deploy to a particular generation of chip or whatever very quickly. What if you just want to deploy workloads? And that is the approach that Enarx took. That's the set of problems that we want to solve. So our design principles are pretty strong. Firstly, really minimal design, minimum trusted computing base. We wanted to trust as few relationships as possible. We want deploy time portability. We don't want you to have to redesign or even recompile your app to run on different systems, different platforms. We decided to put the network stack outside the TCP for safety. I think we all know about security at rest, in transit, and in use, but we are making, again, strong design decisions to make it actually very difficult to do the wrong thing, very difficult for you to save local data unencrypted, or difficult to make network calls, connections which are unencrypted. We want it to be fully auditable because we don't believe that anybody should be trusting code which is not fully auditable and designs which are not fully auditable. And of course, that means for us, that's open source. We also want to embrace open standards so that people can know that what they're using fits those standards. We care a lot about memory safety, and we're also making very strong representations about there being no backdoors, which of course we can back up because it's open source. The first two, you can look at in different ways. This is really important. We do not trust the host or its stack, and we don't trust the host or its owner. The only things we trust on the host are the CPU or the chip providing the TE instance and the firmware associated with it. Nothing else. Not the CSP, none of the rest of the stack, not the hypervisor, none of it at all. And these are the underpinning decisions about how we've designed what we're doing. So a little bit about Enarx. So we use TEs, and the plan is to support as many TEs as we can. SGX, SEV, we are the first targets. TDX we're expecting to do, and there's others out there as well that we're expecting to see. PF from IBM, for instance, has been announced. We hope to support. We aim to make it easy to develop and easy to deploy. Someone already mentioned, I think Simon Johnson, thank you very much indeed, that we don't see ourselves as a development framework. We see ourselves as a deployment framework. I've already talked about our strong security design principles. We aim to be cloud native, which means that we can integrate easily with OpenShift and Kubernetes. And of course, we are an open source project, a part of the confidential consortium. We're one of the first set of projects which were accepted. So I know you've heard a lot about the CCC, but please do go along to the booth and ask questions there. So again, I think we know about these different models. We tend to refer to them as process-based and VM-based. And we don't regard Trust Zone as a TE. It's possible possibly to build a TE from Trust Zone, but not from the basic pieces. And I think Felix touched on a number of the reasons for that. Things like attestation. Also TPM, not a TE in our view. So what are some of the pros and cons in terms of process-based? Well, in a process-based TE like SGX, you've got nice access to APIs, system APIs from the keep, which is nice and helpful. On the other hand, API calls themselves are unfiltered as they come from the keep, which is a bit concerning. You need to redesign your application. The security boundary is, well, compared at least to sort of VMs, untested. There have been some concerns about malware, and of course you're locked in. If you design for SGX or for a process-based keep, you're locked into that. On the other hand, you've got VM-based keeps. Pros there, where we've got a nice strong boundary. You can run application on existing stacks. There's already some bidirectional isolation, which is good, and some malware management. There's other cons, however, around hardware emulation. Not easy. It's rather heavyweight for meta microservices, particularly if you're doing lift and shift for existing applications. And you're looked in fairly much to a CPU architecture. The other concerning one in many cases is that something which is overlooked. CSPs, if you ask for a VM, and typically an AMD SE VM these days, you will get a host-provided BIOS. And that absolutely breaks both of the two first design principles that I discussed. We don't trust the host or anything on it. So we're not happy that you're getting a host-provided BIOS. So what did we decide to do? Well, we decided to go with Enarx. And here's a very basic overview of a kind of standard cloud-based deployment of Enarx. On the left-hand side, you've got a host. That's red because we don't trust it. And what we call a keep. And the keep is what runs in this side, the TE, basically. And in there's an application and the Enarx runtime pieces. Now, we do trust the CPU and firmware, assuming they're attested, of course. But there's an untrusted host agent, which kind of set things up as well. I'll give a bit more data later on in this as well. On the right-hand side, we've got the client. And again, we've got a trusted piece. Trusted because that is what is going to take your workload, encrypt it, and also do all the attestation. And that'll be talking to a CLI or to an orchestrator of some type. So a very, very basic overview of what we're doing. Remember, we do not trust the host. So what's actually inside that keep? What does it look like? Well, it looks a bit like this. So I'm going to spend the next few minutes going through what some of these different layers are in the keep. So the first thing to note is that as far as the application is concerned, it doesn't see any difference between a process-based keep and a VM-based keep. As far as it's concerned, it is just running a WebAssembly in a WebAssembly runtime. WASI is the system API for WebAssembly. WebAssembly, I think we've already heard a little bit about, was originally designed for browsers, but the WASI interface allows use for systems and server type applications. So as far as the application is concerned, it doesn't know and should not care whether it's running on SGX or SEV or in the future any of the other future type of implementations. What exactly that looks like depends on whether it's a process-based keep or a VM-based keep. But basically, the bits that Enarx is providing are the bits which we have got sort of in blue. So we provide a WASI interface and a WASM implementation. We're using WASM time and a shim, which allows those to interact with the lower level pieces without needing to worry what's going on. There's a loader and a kernel which sit outside the keep and therefore are untrusted. And in this case, it's a process-based keep. We're looking at SGX, so that's what's on the bottom. So let's just look at these layers a bit. So at the bottom, we have, of course, the hardware, and that's different between the different platforms, obviously. And exactly what we're building on top of that depends very much. That's the shim and the loader pieces we're talking about. Of course, we need to trust the firmware, and we'll be checking the testing that, of course, as we go as well. The next layer up is WebAssembly. So WebAssembly is a W3C standard. It's a stack machine ISA. It's nicely sandbox, getting some great support at the moment, doing very well in the serverless space, which is why we chose it. And the implementations are improving rapidly. The main ones that are known about are crane lift and WASM time. And as I said, we've chosen WASM time to be the one that we're using at the moment. And WASI is what sits above that in that it's a specific interface. So it's heavily inspired by POSIX, or parts of it, and it aims to be very portable and very secure. It's capability-based, so you can say, okay, I'm going to grant this and not grant this, which is great, actually, because it allows us to decide what we're going to implement, what we're not going to implement. We're basically implementing syscalls below all of this stuff down to the hardware-based pieces, and we can decide what resources and what capabilities we expose to the layers above. The bit above is basically what is created when you compile your application. So as I think, again, we've said, WebAssembly has many languages which you can compile from. If you're compiling a Rust application, you just add the flags -- target WASM32 WASI, and rather than getting a Rust output file, you get a WASM file, which should run directly in this context. So that's all stuff you don't need to worry about. That's dealt with by your compiler. And then, of course, there's your application, which you may have written, may have come from a third-party vendor. And the idea here is that you should choose what you write in. You can write in Java, C, C++, Rust, Go, Haskell, whatever. Do the compilation, and you can now deploy it on any platform that Enarx supports. And you don't need to know what that platform is going to be ahead of time, and the behavior should be the same between all of them. So that kind of brings us to a question, is Enarx a libOS? So this is one way of looking at it. It mirrors slightly what Felix showed, but we have it kind of the other way around. On the left, we've kind of got bare metal, then a virtual machine, then a container, then serverless. And you can think of a virtual machine as abstracting away the hardware, containers as abstracting away Linux, and serverless maybe abstracting away a protocol. And we kind of see ourselves between a container and serverless. We're abstracting common OS APIs, and we're doing that via the WebAssembly WASI interface. That means that you've got just enough legacy support, which allows you to enable the portability without too much difficulty. You've got homogeneity across different platforms. We can also be very careful about what interfaces we support and making sure we don't accidentally leak data to the host. A real problem when you're trying to implement TEs in the container environment, or as we talked about, BIOS, for instance, and VMs. It allows us to bridge these two different models, and we don't need to worry about operating systems at all. We can make things very, very small, and that's exactly what we're doing. So how are we different from libOS? Well, firstly, we're using WebAssembly, WASI specifically, development language neutral and a nice standard. The other thing I haven't mentioned at all is that we handle attestation. So when we saw the picture before with on the right-hand side, the green Enarx client component, that will perform attestation and will refuse to deploy your application, your workload, to the keep unless attestation is successful and is validated. So we handle all the attestation. The application does not need to know about attestation. Our view is that applications shouldn't need to know about this sort of thing. It's irrelevant to most applications. If you're writing a piece of software to serve data or do key exchange, it shouldn't need to know about the environment it runs in. That should be handled by the orchestration And that's exactly how we're doing it. As I said, it allows us to provide a very tight trust model. The only things that you need to trust are A, your application, kind of unsurprisingly, B, the CPU and the firmware, which are cryptographically attested, of course, and C, the Enarx software itself, which is all open source, and we're using Rust, which gives us lots of opportunities and is indeed itself open source too. The other thing, of course, is that the deployment piece is itself key to what we're doing. So it's Enarx cares a lot about deployment. It manages that deployment, and we plan to integrate with a variety of things, including Kubernetes and some IDEs, to make it really, really too easy to deploy stuff. So this is kind of the way we see the world. There are two separate sets of steps. The first step is at the top in a kind of yellow color. You choose your tools that you'll be running, you'll be developing in as you would normally. You develop your application as you would normally, and then you compile rather than to an ELF binary, for instance. You compile to WebAssembly. You've now got a workload which you can deploy, and this is where Enarx comes in. It knows how to. You tell it what host you'd like it to do. It will check that host is can run your application, that TE is available. It will set up that TE instance and set up the configuration. It will then take your application and if the attestation is successful, it will encrypt it with a one-time key, session key, and then run your application. So this is where, the bits that we're looking to integrate with on the dev tooling on the right, then OpenShift or Kubernetes on the left, and whatever cloud you want to be running in on the right. Also Edge. Edge is becoming a really interesting set of use cases that we're seeing coming out. So a little bit more about the architectural view. This is the one we saw before. On the right here, we've got the client agent. That's the bit that does the attestation validation and also does taking the workload and encrypting it and then sending it over to the left. We've got a slightly more complex picture here with a few more of the pieces. So the Enarx client agent on the right is obviously going to need to look at measurements for attestation to be sure that what it's doing is correct. It'll want to be taking, we need to be loading the runtime images for the Enarx runtime. So we need a runtime repository. The keep manager, which as I said before is untrusted, is on the bottom. And then in green, in the green box, we've got the bits that we care about. A shim, which abstracts away the different architectures you're running on, the attestation piece, which sits inside the keep as well in most cases, the app loader, which talks to the client agent, takes that that code, that WASM file which has been encrypted, and then loads it, and the WASM itself, the WASM runtime itself, which does the running. And then, of course, you've got the application on the top. And we have working code for almost all of this. We haven't written the contract manager, not required at the moment. We haven't done the attestation measurement database. We're just doing that by hand at the moment. But it is all running. It's all testing, and we can deploy via HTTPS directly. We are absolutely an open project. By which I mean not just the code, but our design, our issues and PRs, our chat, our CI/CD resources, our stand-ups. We have adopted the Contributor Covenant CFC. What's that stand for? I can't remember, but Code of Conduct. There we go. You can see whatever you want and get involved. And we'd love you to get involved. So stand-ups are open to all. You can check a website wiki for details. We have a chat server. Everything is Apache 2.0 and in Rust. One thing I would add is that we are currently unfunded, which is obviously slowing down what we're doing. Initial funding was by Red Hat, but that has been dropped over the last month or so. So if you're interested in funding, we'd love to talk to you. We think it's a really interesting project, and we'd love to have the opportunity to work with you, or just for you to get involved. Of course, anyone can get involved in their own time if they'd like. So I'm actually going to stop it there because I wanted to leave as much time as possible for questions, because we are a slightly different approach to some of the other folks out there. So I'm going to stop there and see if I can go back to the stage and stop sharing. How do I stop sharing? Have I stopped sharing?
No, you haven't. Yes, you found it.
I have. Okay, fine. So I talked very quickly. I got through a lot there, but as I said, I really wanted to leave time for some questions. So what have we got? Any questions? I have a beer as well, so that's good.
I'm still running on Coke. Okay. First question was, does it mean that Enarx supports the standard JVM CLI tooling?
Sorry, I didn't get.
Does it mean that Enarx supports JVM/CLI? I guess the question is if you can use normal Java tooling to.
Oh yeah, sure. So you can absolutely compile from Java to WebAssembly. Yes, so you can write in Java, you can write in Go, Rust, C++. It's all part of the standard tooling. Java's slightly different, but Java's always slightly different. But yes, you can compile directly to it. I don't think it's part of the standard Java C libraries at the moment, but there are things you can get. There are projects to do exactly that. Yes, very much so. And I've done it.
Are there any limitations? Like, can you run very complex Java applications, or are there certain limitations?
So we haven't done much of that yet. We're still fairly early stages in the project. The answer is we expect most things to be fine. We are the two main things that in our prototype stage, well, proof of concept stage we're at the moment, which we have restrictions on, are one, storage, because we want to be very careful about how we manage block storage, because it's very easy to leak information even at the metadata layer to the host. So we're being very careful about that.
Yes.
There's actually, we're very close to proof of concept on that as well. And the second is networking. As I said, we don't want you to be able to create, well, without difficulty, unencrypted connections out. So everything will be transparently TLS. So there's obviously some quite complex pieces around that about certificate management that we're working on at the moment, which mean that currently it's quite difficult making network connections or, in fact, storing anything, which does restrict somewhat what you can do. But we're actually pretty close to those. So it shouldn't be long.
Yeah, no, that's super interesting. I think one important puzzle piece in making CC more usable is having transparent TLS connections based on remote attestation. I think that's super interesting.
Absolutely. So the way we do the loading of the initial workload is based on creating TLS, self-signed TLS certificates based on the attestation data. So we create, we do that based on the attestation. Now, exactly how that works depends on whether you're using SEV or SGX, and that's part of the reason for the complexity of the attestation pieces. But yeah, we generate a new TLS, and we do both. We make sure that there's information from both sides. So we know that you should only be connecting from the client which requested it, and the client can be sure that it's connecting to a validated TE instance that it requested. So we're doing that, and so the plan is also, obviously, having done that, to set up and to allow certificates to be provisioned again, either transparently or in the future with some more input from the application framework, so that you can do that. But the plan is to make it generally as transparent as possible.
Yeah, sounds great. So I was wondering, do you have already support for the new SEV SMP remote attestation?
So we actually started with the original. Which one do we do? SEV. We have SEV. SMP is coming. I think we've been working on it, but I'm not sure it's actually fully released yet. But yeah, so we'll be supporting both, and we have SGX as well. Also working. So yeah, we plan to support all the different ones as they go forward.
Awesome. Do you have SGX decap then?
I think we use decap. So we don't. We never make calls out in real time. So we are using the what do they call it, the attesting enclave that SGX creates. The way they do it is slightly weird. Well, from our point of view, the Intel way of doing it is slightly weird. So we've been working with the engineering team to cut down to the bare minimum of trust pieces what we need to do and use that. And Intel have been great about that. I should be very clear. They've been very helpful about that. But we're not making calls out in real time to Intel or to IBM or to AMD or whatever to find out what's going on. So the plan is that you should be able to deploy this absolutely in a closed environment if you need to as well.
Yeah, no, makes sense. There's another question in the chat regarding threading.
That's a great question. Yeah, okay. So we are currently single-threaded, and that's tricky, obviously. So on SGX, as it exists at the moment, that will probably continue to be the case. The plan is to allow multi-threading on SEV by adding vCPUs. That's not implemented yet. It's on the roadmap, but that's the plan we the plan we have to support that at the moment. It's a really interesting question, and how you map that to the runtime you've chosen, and in our case, WASM time, is complex. It also actually makes some of the implementations at the lower level as you're doing attestation quite difficult, because you need to be running HTTPS sessions and listening on stuff and then responding to that. So there's actually some challenges even before you get into the runtime, which I think we've dealt with actually. But it is pretty complex, I have to say. And Rust is pretty good at this sort of thing, and is very good at protecting you from doing the wrong thing. But it doesn't mean it's easy to do. I've had to write some of that code, and I only learned Rust. I only started learning Rust about March or May last year, and I'm now writing production code, so it's quite scary. Okay,
yeah, I still have it on my list.
Oh, it's a lovely language. I mean, I love it. If anyone's interested, I've got some blogs on my articles on my blog, which is aliceevebob.com. aliceevebob.com, which is hilarious if you're a crypto person and not very funny if you're not, it turns out. About Rust and coming to Rust from Java, which was my previous main language. I love it. It's a great language. It makes it so difficult to do the wrong thing, and I think from a security point of view, that's something we've embraced as Enarx as well. We want to make it difficult to do the wrong thing. That's our approach.
No, makes perfect sense. I have another. Or do we have?
No, we don't. We don't have time. We have the time slot is ending right now.
Okay, we have a breakout in a couple of hours. I will be here for that. Please do that, or find me on LinkedIn or at the CCC booth. I'll be there as well. Thank you so much, Anna-Lena and Felix. Really appreciate it. Cheers.
Great job.
Thank you so much.